Because K values are determined from a ratio, the magnitude, relative to 1, indicates whether the numerator or denominator is going to be larger. So we'll consider an example of nitrogen monoxide reacting with bromine gas. The equilibrium expression has products over reactants. So, because Kc is less than 1, it indicates that the concentration of the reactants are going to be much greater than the concentration of the products at equilibrium. That is to say, the bottom part of this expression is going to be larger than the top. When you have this kind of condition where K is less than 1, the reaction is said to lie to the left, or that the reactants are favored. And then the opposite is going to be true as well. Where Kc is larger than 1, at equilibrium, the product concentration is going to be greater than the reactant concentration, and the reaction will lie to the right, or products are favored. So K values are based on K expressions, which are based on reactions that are written out in a single direction. And if you change the direction of the reaction, you're going to invert the K value. And we'll use that nitrogen monoxide and bromine reaction again. With this reaction, nitrogen monoxide and bromine are your reactants, and NOBr is your product. So the K value for this we've already seen is 0.013. However, if we write this reaction in the opposite direction, where NOBr is the reactant and NO and Br2 are the products, we're going to have to write our K expression inverted. Because we've reversed our reaction, we've inverted our K expression, and that means we invert our K value as well. It's possible to write a K expression for a reaction that consists of several equilibria happening in sequence. So consider the reaction with NOBr and chlorine gas. This reaction can be written as the sum of two individual equilibria. This reaction provides the bromine gas for the second part of the reaction. And you should be able to see that if you treat these reactions like we did when we looked at canceling out spectator ions, the overall reaction will be 2 NOBr plus chlorine gas gives you 2 NOs and 2 BrCls. And now we'll write the K expressions for each of these reactions. You can combine these two K values to get the K for the overall reaction. And if you check the original multi-step reaction, you can see that if you were to write a K expression for that, it's equal to the one that we've just calculated. And if you multiply the two numerical values for K1 and K2 together, you find that the overall K value is 0.094.